Alright, so permutations problem from the CSES problem set. Let's go ahead and read the instruction here. A permutation of integers which goes from 1 up until n is called beautiful if there are no adjacent elements whose difference is equal to 1. Given n, construct a beautiful permutation if such a permutation exists. And the input is, the only input line contains an integer n, and the output is print a beautiful permutation of integers. And if there are several solutions, you may print any of them. If there are no solutions, print simply this string, no solution, okay? And n here is up until 10 to the power of 6, which is 1 million, which is a relatively small number. So this should be doable in a linear time, because essentially we're gonna output n numbers. So big O(n) solution will work here, okay? And here we have the example inputs and outputs. So 5, for n equals to 5, this is an example of a beautiful permutation. And for 3, we have no solution. This can be, this is obvious if we observe that number 2 will either have to be next of 3 or next of 1, at least, in any permutation. So it will always have an adjacent element that has a difference of 1 with it. So we output no solution in this case. Let's go ahead and look at the solution now. So the solution I have here is a pretty simple one. So first of all, I have these two if statements here, which is the edge cases, where n is small actually. So if n equals to 1, we have to output simply number 1, okay? It's just one element, it has no adjacent elements. So by default, it will not stop the array, the permutation, from being beautiful. The other case is if we are not equal to 1 and we are equal to 2 or 3, so that means we are less than 4, there is always not going to be a solution. Because again, for number 3, we explained it before with the sample case. For number 2, n equals to 2, then 1 is always going to be next of number 2, and their difference will always be equal to 1. So the permutation, there is no permutation that can be beautiful in that case. Now, after we have executed these if statements here, so we know that now, if we reach this point, n is greater than 3, so it's equal to 4, or greater than 4, essentially. And then that means we can construct the following solution. First of all, we print out all of the even numbers, and then all of the odd numbers. So let's look at the while loops here. So I set a variable which I call even to be equal to 2. And this even variable will go up until n at most. I output the variable every time, and I increase the variable by 2. And then I start with the odd numbers. And the same goes for the odd variable here. It goes up until n, and I output the variable, and then I increase its value by 2, okay? So it's obvious to see that the first segment, which is all of the even numbers, we always have a difference of 2. So let's take for n equals to 4, okay? Then you have number 2, and then you have number 4, okay? And then you have the odd numbers. So we begin with the smallest odd. So when connecting these two segments, the even segment with the odd segment, the first number for the odds will always be 1, and the last number for the evens, okay, it will be the greatest even we have in the range between 1 and n. So for sure, the difference between that even number and the smallest odd number will not be equal to 1, okay? So the only case that you have a difference, an even number which has a difference of 1 with number 1 is 2, okay, for all of the positive integers. And since 2 is the first even, which will be followed by other even numbers, the last even number will never actually have a difference of 1 with the first odd number, okay? And that's the constructive solution, essentially. For the segments themselves, you can see that because I'm adding 2 every time, the difference will always be 2 from all of the adjacent elements that an element has in these segments, okay? And then I just simply output the end line. So that's pretty much it, the solution. It's a constructive problem, okay? You just construct the solution by making the observation that I just described here, where you just put the smallest odd number being followed by the greatest even number, okay? If you guys like this video and it helped you solve the problem, if you got stuck with it, please leave it a like, subscribe to the channel, and I will see you in the next one. Goodbye.